Oh, okay. Okay, so hello everyone, and welcome to the Innovations in Aging Research webinar series. I'm your host for today. It's afternoon in your time, it's morning in my time. So my name is Noemi Maureen Lansang, and my research interests are in the domains of geriatric rehabilitation, cognitive rehabilitation, sound and acoustic rehabilitation, and martial arts in rehabilitation. Quite a mouthful. All right, so before we start our episode with our distinguished guests, let me just plug in some acknowledgements and some reminders. So kicking it off, this webinar series is brought to you by ACRM Aging Research and Geriatric Rehabilitation Networking Group. And you can see in your screen our link. So I would like to invite everyone to check out our networking group. We have great people here. So if you like to join in and you have projects in mind and would like to collaborate, kindly drop by our meetings or contact our chairperson, Dr. Patricia Hine or Dr. Amit Kumar. And maybe you can find people to work with, and you can find your niche in our task forces and have great fun with our awesome members. Okay, so next we have I would like to plug in ACRM's call for members. So please check out our website, acrm.org/join, and see the rates and benefits of becoming a member. And while you're at it, kindly check out also our 99th annual conference. It's happening in November in Chicago. It's the much awaited face-to-face conference. So after a long while of being virtual, it's nice to see each other in personal appearances. So kindly check out the rates and schedules and see if anything in your suit taste your suit. All right, so lastly, just shameless plugging on Prospectus. So this is an ACRM journal. It's out in the open. So if you're interested to promote your papers or boost your advocacies, kindly contact our sales department. It's acrm.org/sales. Okay. All right. So let me introduce to you our speaker for today. So for this episode, we are graced with our dear speaker, Dr. Jeff Leismer, and he is speaking on the use of therapeutic vibration technology in persons with movement disabilities. So I do want to advise everyone that this meeting is being recorded, so please keep your phones and microphones on mute and keep your cameras turned off throughout the presentation. We do expect to have about 20 minutes available for discussion at the latter part of the hour. So if you have questions, please type them in the chat feature and we will address as many of those as you can. You are also welcome to voice out your questions later on if you're more comfortable speaking them out. So let me introduce our speaker today. Dr. Jeff Leismer is the founder and CEO of Vibetech, a NASA spin-off company, and he leads the company's creation of advanced robotic therapeutic vibration rehabilitation solutions that make exercise accessible to everyone. He has been an invited faculty member at ACRM and presented at numerous conferences and events. Dr. Leismer is inventor on over a dozen issued and pending patents and holds a PhD in mechanical and aerospace engineering from the University of Florida and at MEng in biomechanics and a BSc in biomedical engineering from Michigan Tech. So ladies and gentlemen, I present Dr. Jeff Leismer. Doctor, the floor is yours. Let me just turn off, stop sharing, and then the floor is yours.
Great. Well, thank you, Noemi. I really appreciate the introduction and being a part of ACRM and the Aging Research and Geriatric Rehabilitation Networking Group. It's been fantastic to collaborate with everybody, so thank you. I am going to share my screen here, and hopefully it works properly. Let's start the presentation. All right, here we go. So we've got a few pictures of some of our equipment that produced over the years, and you'll get to hear my talk on using therapeutic vibration technology in mobility impaired patients today. So some disclosures: I am the founder and CEO at Vibetech, which is the company producing some of the technology that will be addressed in this presentation. As Noemi said, I am the inventor on about a dozen patents now that pertain to the technology presented here. And I do have ownership interest in Vibetech. So I'm going to present things according to the learning objectives here. So we'll kind of go in order, focusing on helping you to understand the importance and intricacies of our mechanical interactions with the mechanical environment, particularly focusing on those mechanical interactions that are responsible for influencing the form and function of the musculoskeletal system. We'll contemplate what are those active ingredients of weight-bearing physical activity. We all know drugs have active ingredients, but so does physical activity. So distilling down to what are those key ingredients and being able to reproduce those through a machine and properly dose them, that's what this talk is about today. So that was objective 1. Objective 2, we'd like to make sure that you have an understanding of biomimicry, copying nature. Nature's solved problems for humans for millions of years. And biomimicry is something that can be used to solve design issues all across the board. You look to examples in nature for how nature's solved problems, and then you can recreate that and copy it. And that's what I did with Vibetech and therapeutic vibration. And it was actually practicing the art of biomimicry that led to the genesis of Vibetech. So we'll talk a little bit too about collaborating and trying to work together with everyone in this audience, whether you're live or you're watching this recording, but to try to do things that can help increase accessibility and engagement with therapeutic vibration. I'll kind of highlight some of the things that we're working on right now, that on the gamification and the virtual reality side of things. But those are things that are all in development that I'm excited to bring to fruition. And I'd love to collaborate with folks on the clinical research side and other areas. We'll take a close look too at therapeutic vibration and this robotic assist technology that you actually see right behind me. This is the Vibetech Pro. It's a therapeutic vibration dose delivery system to make sure you can deliver the proper dose of vibration to the parts of the body that need it the most. And we'll get into a little bit about why you might use that. So including increasing strength or reducing atrophy in the event of an injury, surgery, or illness, or laziness. Disuse atrophy affects people that are lazy too. Increased range of motion, reducing pain, circulation improvements, improved balance and physical confidence are all things that can be achieved with therapeutic vibration when applied correctly. So now it's learning how to use the tools available to you to achieve optimal results. So looking at this, if exercise helps improve all ailments, how can we reimagine exercise for those with the largest barriers and those with the most barriers? So I believe we have a chat feature here. If you're conjuring up images of people with a large barrier to physical activity, what condition or conditions come to mind? Maybe it's an individual that has multiple comorbidities that you're picturing when you're thinking of, wow, they can't exercise. And then during this presentation, we'll start thinking about they can't exercise with the current tools available to them, but now using some new technology, these folks will be able to gain access to exercise. So I'd love for you to just, make this interactive, share in the chat feature, the condition or conditions that you can think of that just come to mind when we talk about barriers to physical activity. All right, got to look a little sideways at this one, but what does reduced physical activity look like? So this is a chart that I came up with that kind of shows strength and mobility as a function of age, starting from kind of midlife. And we're showing how as you age, you initially don't need assistance from others or technology to go about your day-to-day activities. But as you get older, you start to require assistance from people and others, to the point then that you get so far down the road and reduce strength and mobility that you become reliant on devices and others to help you with your daily activities. There aren't a whole lot of solutions for people that rely on technology and others to help them with exercise and weight-bearing exercise. So that's been my area of focus. Also, in younger ages, you can have injuries and surgeries or illnesses that suddenly drop your strength and mobility level. You might get most of it back, but likely you're not going to gain 100% of that back. And over time, those injuries stack up. And so it's going to really shorten your strength and mobility age. So coming back to learning objective 1, let's take a look at those dynamic mechanical forces that sculpt our bodies. So I got my start in biomedical engineering looking at astronauts and what effects disuse atrophy has on their body. So microgravity in space, near 0 G's of acceleration acting on the body. If we go to Mars and put the 1 million people on there that Elon Musk wants to do, that's 3/8 of Earth's gravity. The moon, if we establish a base there, is only 1/6 of Earth's gravity. So our bodies have evolved around the dynamic forces at 1 G of acceleration that we handle here on Earth. So in space, you've got astronauts. On Earth, you've got, for example, an athlete. Now, okay, the legs are a little bit sideways on this one, but you can see nice, thick, strong legs with lots of muscle on the athlete. But then on the astronaut, you've got the chicken leg syndrome, where the legs are actually reduced in size and the atrophy that occurs very rapidly. But I got my start studying bone loss in astronauts and realized that that was a really, really good focus because everything about our musculature kind of builds on what happens to the bones. So the bones are a good barometer of our daily exposure to weight-bearing physical activity. So as we age, we lose bone mass and our bones break. In space, you lose bone mass because of lack of gravity and a lack of motion and dynamic forces on the body. And so astronauts actually lose bone mass 10 to 20 times quicker than an older adult in their weight-bearing bones. So impressive fact right there. Now, you've all seen Jurassic Park. When the T-Rex is coming, they know because you see the glass of water with the ripples in it. And those ripples are actually a result of the impact vibration as the T-Rex is walking. Well, every step has an impact for humans too. There are impact vibrations that come back up through from the heel bone on up through the lower leg, up into the femurs, and then up into the spine. And so that force of impact, it's not just a big sudden increase in force that spikes, but you have a bunch of little tiny spikes with vibrations that are occurring as well. And I'm going to show you how that is a very important thing because our bodies have evolved to develop a tonic vibration reflex to protect against our soft tissues like our muscles and our fat and everything, connective tissues that are going to bounce around uncontrollably if we don't protect them by having our muscles contract through the stretch reflex. So muscle adaptation occurs initially through muscular education. So the first 8 to 12 weeks roughly of a new exercise program, your body is kind of recruiting new neuromuscular patterns to be able to help boost your strength. After which time, then your muscle size starts to increase, and you can even have your fiber type adapt from fast twitch to slow twitch to fast twitch, depending on the types of exercises that are being performed. our bones are also always remodeling according to the stresses that act on them. So if you're inactive, your bones get thinner. In particular, the spongy bone, the trabecular bone on the inside of long bones, is going to get weaker with physical inactivity, but it'll grow stronger, more dense, and even the architecture of the bone will change when you apply increased forces to the bone. And so the direction of loading and how you do it is a very important thing. And that, again, was why I got into the field that I did. I wanted to become a bone architect for people with weak bones, to sculpt bones in unique ways through the use of dynamic forces. And lo and behold, I came across a signal that happens all day, every day in nature that not only provides a stimulus to bone, but I found that my muscles got to work out too. From my first prototype therapeutic vibration device, sitting there doing nothing but having this contraption applied to my leg, after 10 minutes, it was very comfortable, but I couldn't stand up because my leg muscles were completely exhausted. So I knew I'd found a signal that was really, really key, an active ingredient of physical activity. By copying nature and applying that same vibration frequency back to the body and using forces to help transmit it to the leg, I was able to then evoke this stretch reflex that at the time I didn't even realize we had. I was just like, wow, I got a workout for nothing, effort-free workout. And since then, I've refined the technology, the stimulus to be as ultra safe, as well as then to optimize the protocols to be able to maximize the outcomes for folks. So what we know is that mean and alternating forces. So mean forces are, kind of like a compression load that, from the standing forces on our body, applying force to our leg bones. But there are alternating forces from impact. So the vibration force alternates up and down, and those forces dominate our active lives. And an increase or decrease in these forces results in musculoskeletal adaptations. So what we don't thoroughly know yet is how to quantify weight-bearing physical activity in a manner that allows for us to, measure the weight-bearing physical activity and correlate those active ingredients back to the physiological adaptations that are happening. So again, going to the chat function, if you would like to add some comments about how you quantify weight-bearing physical activity and correlate it back to physiological adaptations or outcomes, I'd love to hear from you on that. And absolutely, let's work together to come up with the best practices for quantifying weight-bearing physical activity. It's something I'm passionate about and just getting started at doing here. So the second learning objective is focusing on mimicking the natural signals that shape our bodies. So as somebody's walking, they put their foot down, and that's the loading phase, where those forces transmit from the heels on up through the legs and up into the spine. And there are vibrations from the impact, but also because those vibrations are happening externally, that then transmit through the body, that natural stretch reflex occurs. Well, our fast twitch muscle fibers contract at a matching frequency to cancel out those vibrations. So then we have internal muscle forces pulling at a frequency of vibration that occur every time we take a step. So adaptation occurs over time with repeated loading, where you get stronger over time and your bones become more and more dense. Or reverse if you're less active. So therapeutic vibration, it's low frequency mechanical vibration applied for therapeutic purposes. It's not electrical stimulation. Aside from electrical stimulation, it's the only way to contract the muscles without effort. It can be tuned, it can be safe, but we have to be careful because there are unsafe levels of vibration. as I mentioned, this technology that I've developed was reverse engineered from naturally occurring vibration, that occurs in the natural environment. We can use short term, we can do nerve and musculoskeletal or skeletal tissue stimulation, which there are benefits to activating muscles, tendons, and ligaments. But over the long haul, we're actually sculpting those tissues. Even neurological reeducation can occur over time. So what we're trying to do is improve musculoskeletal strength and function, circulation, and pain. And sensation. That's something that we have been discovering is a benefit of treatment. And we've done a number of studies now that have looked at sensation, and we keep on seeing that people have increased sensation as a result of this stimulus. Now that's contrary to some of the work that's been done out there, looking at vibration and some of the neurological damage that can occur, and some of the processes that allow for you to get used to a mechanical vibration that make it so that you become less sensitive to it. But here, we're actually showing that this particular frequency of vibration is actually increasing foot sensation. So that can be great for people with diabetic neuropathy. So dosing parameters, I like to define those right at the interface of the vibration source and the body. There are safe and unsafe doses of vibration. The International Standards Organization has a number of different parameters that are kind of limit the exposure level to vibration or duration based on the intensities and the frequencies of vibration applied. So the key things to me are, well, how long are you doing it? What waveform is being used? Sinusoidal is what I like to apply through my equipment. Frequency dependence is really important. Outside of the range of natural stretch reflex stimulation through the tonic vibration reflex, there can be problems that the body has because we haven't evolved to develop a mechanism to handle those vibrations. But within that tonic vibration reflex range, which is about 20 to 60 hertz, we actually have very positive outcomes through the stimulation when we're deficient in weight-bearing physical activity. Alternating forces are really key, and I prefer the alternating force to be something that's expressed as opposed to an acceleration magnitude. I think there's more information that we can gather from that, because anything that, if you've seen a whole body vibration platform, you have most of them apply vibrations at greater than 1 G of acceleration. So you might have somebody that's being pushed up by a vibrating platform that actually lifts off of it before coming back down, maybe riding smoothly, but maybe on the next oscillation, you get an extra oscillation in there and you get an impact. So anything over 1 G of acceleration, the input to the body does not match the output of the machine. So you're not getting the same frequency. You also might get some impacts, which could cause some frequencies that you don't want to have when you're applying vibration over 1 G of acceleration. So the G force, it's a good thing to report, but the alternating force and the mean force are the key things right there to look at. ISO 2631-1 is the standard that governs human exposure to whole body vibration. And so it's really been designed for people in an occupational setting where they're exposed on a daily basis based on power tool usage. Like picture a jackhammer operator that develops neurological damage from that. Truck drivers bouncing around, developing low back pain from bouncing around from a non-air cushioned seat when they're driving 8 hours a day. So overexposure can result in nerve, vascular, and musculoskeletal tissue damage. So you have to really pay careful attention to that dosing that's applied. And again, looking at the interactive nature of what we're doing here, I would love for you to let me know if you would be interested in contributing to the development of new standards surrounding therapeutic vibration. So I'm on the US advisory group that reports to the International Standards Organization. So we're responsible for reviewing existing standards, modifying them, as well as generating new standards. There is a lack of standards in the therapeutic vibration space, and I'm currently starting to recruit potential committee members. So if you're interested in lending your expertise in the field, I would love to talk with you. If you're interested in helping plug some holes in the literature on whole body vibration or limb specific vibration, I would love to talk with you about conducting some studies that might help us learn a little bit more and make sure that we have a full understanding of every aspect of how vibration treats every biological tissue, how it affects the function of those tissues, affects the organism as a whole, the human as a whole. So reach out to me. Jeff@vibetechglobal.com is my email address. And you can also put a note in the chat if you're interested in learning more, or putting your name in the hat of potential committee members. Getting into the topic 3 here. So this is where we get into using tools to help deliver those vibrations directly to where they're needed, based on the condition or conditions that you're trying to make better. So I'll be talking specifically about the robot-assisted therapeutic vibration technology here, and I'll give a demo of the Vibetech Pro. So you can see some of the technologies on this slide that where we started. Our initial funding came from a grant from the National Institute on Aging, and that was the first clinical prototype that we developed, and that's the one pictured at the left. So we actually had it rigged up in a hospital bed with the back inclined to a semi-recumbent position. We had straps over the knees to fix the knee joint angle at roughly 25 degrees. And then we had a track and mechanism to apply loading to the legs, where you'd apply the load, but the knees wouldn't bend any further. So it kind of simulated somebody standing, even though they were laying down in bed. Then we transmitted vibrations through the feet. And that quickly evolved into a chair-based design, having something that could be used in therapy departments, whether it's OT or PT. Both settings work well. But what we also found is that people in long-term care can really benefit as well. It's not just a good treatment, but it also is a great tool for preventing issues from happening, preventing physical decline, as well as for performance enhancement. So for an athlete to be able to have improved performance, or the everyday person, or even somebody that's in a state of decline, we're really boosting that performance is what we're doing. So through activation of the muscles, people are stronger, more flexible, they have less pain, better coordination, better balance. So it helps across the board. It's a universally applicable technology. I've just really focused on refining it to make it useful for those with the greatest barriers to physical activity. You can see on the right side, that's our Vibetech 2 machine. That was the second generation device that we incorporated a auto dosing technology into it. So it measures your strength right on the machine. It measures your range of motion. And based on that, it assigns you a protocol that you can keep up with for 10 minutes. That's pretty challenging. But it also has a passive mode. So if you can't physically push, it can move your legs back and forth while vibrating. We now have the Vibetech Pro. I'm just going to click on that so you can see what it looks like in 360. So this is a device we designed to be more accessible from a chair or a wheelchair. It's on casters, so you can bring it to somebody who does not have the mobility to get up and then to transfer into a chair. So this was something that we've been kicking around the idea of a smaller, more of an ottoman type of design. When Deb Jacoby, who was the life enrichment director at Rocky Knoll, the facility I'm actually sitting in right now in Plymouth, Wisconsin, she was working as life enrichment director, working with memory care residents, and thought that the Vibetech 1, which had its own seat, would be a great tool for them to be able to exercise in. We found out they could tolerate treatment very well. And then a quality assurance and performance improvement, or QAPI study, was performed, and they found that the residents that partook had a 45% reduction in falls during the 3 months they received treatment compared to the 3 months before. But the one problem was they were only getting 1 or 2 treatments in a day, or sorry, 1 or 2 treatments a week. These were 10-minute sessions. They realized that this could be benefited from not having to do a wheelchair transfer. So we said, let's shoot for some grant funding, which we were able to leverage from a local foundation, develop the technology, and now this is actually the first device that we were able to produce out of that. So we've got 5 of them right now, and we're just getting into production. So a new exciting time for us. We're now picking up another study here at Rocky Knoll, working with a lot of the long-term care residents. So it's definitely an exciting thing to do. So on the device, you can do leg presses actively or passively. So again, the foot plate can move back and forth through a comfortable range of motion. And it's a limited range of motion that really is designed to mimic the motion as well as the forces that you will feel if you're walking. So with your feet raising up just a couple of inches off the ground, that was the motion that we really wanted to be able to allow for somebody to feel. The force is pushing right through the person's center of gravity. So even though they're seated, they can actually train themselves to have improved balance. So with those forces helping transmit the vibrations, we can really use that to direct the vibrations anywhere from the feet, if they have neuropathy, all the way on up to the knee. If they have knee pain, a nice 25, 30-degree knee flexion works really well for alleviating knee pain. Or if they keep their legs straight, those vibrations, and they're pushing through their heels, those vibrations come up through to the heels to the hips and to the low back. So if they're recovering from a hip surgery, hip pain, low back pain, there are some really good ways to work this. So we're actually building in strength assessments to this equipment. We have data analytics capabilities where the data is reported to a cloud server. We analyze that data and can report that right back. And so you can get information about how you're doing and how you're progressing. We have done some telemedicine treatments with the Vibetech 2. We're looking at incorporating those into the Vibetech Pro as well, which is a great way to be able to minimize staffing requirements and allow for treatments to take place wherever. Rehab gaming is another really exciting thing that we're developing. So this foot plate serves as a controller for playing video games, where you're actually doing leg presses to interact with a game. We have some teams, some student engineering teams that have prototyped virtual reality games for us that we're just about to start testing. So it's a lot of fun here to make this much more engaging for people. I'm just going to share a quick video showing Deb wheeling me up to the Vibetech Pro. Getting the footrests out of the way, and then placing my feet on there. And the way we set up for this particular video is so that my legs are straight with the foot plate as far out as it can go, and that allows for me to do leg presses. Kind of small little leg pumps. We can start off with taking into account of if somebody has pain and where that's at, and you can kind of see some of the interactive features on the screen where you get to see a plot of the foot plate position versus time. So you can actually kind of draw hills and valleys and kind of interact with the machine that way. So from bigger pushes to little pushes to just holding your legs straight, and there are some dynamic forces acting on your body, pushing with the balls of your feet, pushing with your heels, alternating left leg, right leg, pushing the outer edges of your feet in or the inner edges to work the different sides of the ankle complex to help improve balance. And then straightening out my legs here, and then turning it into a nice hamstring and low back stretch. So again, very versatile machine. Even doing some little toe raises down there at the bottom. And then realize that we can even do some arm workouts here. So just keeping your legs straight in the wheelchair locks off. You can pull yourself into the machine. And there are some vibrations that transmit through the handlebars. So you're actually getting a little bit of a workout for your hands and your arms as well with it. So I'm going to highlight some of the clinical outcomes, and I've got a handful of them with individual graphs a little bit later on, but we've now been presenting at ACRM for the last several years. And we've had a handful of poster presentations talking about a 20% gain in strength after a 10-minute session, to a 32% gain in sit and reach flexibility, to a 66% reduction in pain, all from a single treatment. I mentioned the fall reduction, but the strength gains are really impressive. We had one woman with diabetic neuropathy that after 12 weeks of receiving treatments on average once every 10 days, these are 10-minute sessions, she had 3 times stronger leg muscles on her leg that was affected by foot drop. And her foot drop had dramatically declined as well. And she learned to control for her foot drop much better. So she became much less fearful of falling after those 12 weeks. Enjoyment is an important thing. So finding out that the majority of people really do enjoy that treatment. One of the key discoveries that I had was early on in development, sweeping through different frequencies. I found that there was an involuntary muscle force development that occurred, and I swept through to find out what frequency worked best and arrived at 30 hertz worked best for those that I tested. So that's what our machines currently use. 25 to 30 hertz tend to be the frequencies that are used or reported in the literature for whole body vibration, showcasing a lot of the best benefits. So that's a good range to work with. But below 20 hertz, there's no benefit to the vibration in terms of being able to cause the muscles to contract involuntarily. Beyond 60 hertz, there's also no benefit there to the muscles. So I'm going to skip through some of these things, but this just shows that people get stronger with the number of treatments they receive. This was the case study with a woman with diabetic neuropathy that improved very rapidly, 22 pounds of added strength in one leg per treatment, averaging 20% gains in leg strength in the 52 people that we tested after a single session. After 8 weeks, a 29% gain in leg strength in older adults, frail older adults. Sit and reach flexibility improved dramatically in one of our early studies that led us to incorporate technologies to measure it on the machine, which this study did, with 46 people showing a 32% gain in passive squat depth right on the machine, 66% reduction in pain. Now with the foot sensation, people were able to sense more points on their feet after vibration than they could before. We did another study where towards the bottom, we reduced neuropathy symptoms by 40.8% after a single treatment. And so that was a really impressive find right there. And how long do those symptoms stay at bay? Well, the majority of people said that they still had those that relief up until their next treatment, and they were receiving 2 treatments a week on a Tuesday or a Thursday. So it was 2 to 5 days later, and they still felt relief from that prior session. So some of the key takeaways here are that, the only things that help improve every condition are exercise and nutrition. So Terry Sullivan's been involved with our group for a little while now, but it's a profound statement. There aren't many things that can benefit everybody. You look at drugs, pharmaceuticals, and there are so many contraindications. Exercise, as long as it's being done in a safe manner, can benefit absolutely everybody. And that's what robotic therapeutic vibration is all about, is delivering that proper dose of vibration. And as I mentioned earlier, therapeutic vibration is an active ingredient to physical activity. And every time we take a step, it's present in that impact, as well as every time our muscles contract, that vibration is present. So there's new technology being developed, and you see some of it behind us, behind me here, to really properly dose vibration for absolutely anybody. The very first person that I had using our equipment outside of the Vibetech office, I gave this to a quadriplegic who for 25 years has been living with his spinal cord injury. And he had his assistant help put his legs on the device, and it just moved them back and forth. And he used that a couple times a day for 2 weeks. And when he was done, he's like, that was just really easy to use. And one of the neat things that we saw with him was a reduction in swelling in his leg. So it was helping with some of the edema. So that was a great thing, but that's something that I'd like to do more studies with. So some parting thoughts here. So hopefully you've been gathering up some ideas on questions. These are your parting thoughts. So think back to the beginning of the presentation when I asked you which conditions come to mind when thinking about barriers to exercise. And then imagine how you'd use this new robotic therapeutic vibration equipment to treat those individuals. What protocols might you follow? What outcomes might you seek? And be sure to reach out to me if you have any interest in learning more about partaking in clinical research studies, collaborating with the new standards that I'm working to put together for the therapeutic vibration industry, or if you have any questions that you didn't have answered thoroughly in this webinar, I will be available to you. I also wanted to say thanks to Rocky Knoll for letting me use the facility today, but also for helping define user needs and for providing design feedback for the VibeSet Pro. So thank you again. You can see my contact info and jot that down. And if you reach out to folks from ACRM, they'd be willing to share that with you after the presentation as well. So I'd like to turn this over to you for any questions you might have.
Okay, all right. Thank you so much, Dr. Jeff Leismer. So are there any questions from our audience for our speaker? None yet. Okay, yeah, go ahead.
Yeah, go ahead. Oh, no, after you.
Yeah, I have actually a few questions while I was listening to your speech. Your webinar. I was wondering, Doctor, how do you account for user feedback? Like there are patients who are who cannot really feel the vibration, but we know that vibration is good for them. So how do you handle these kinds of cases? Like they can't feel the vibration. So,
and that's an important thing. Being able to be aware of the sensations of the mechanical forces acting on your body, it's helpful. But yeah, depending on the situation, like the gentleman I mentioned that's been living with a spinal cord injury for 25 years, he has no sensation below his neck. So we were monitoring, looking at his legs, looking to make sure that we weren't seeing any additional, skin breakdown, anything like that. Because he normally has wraps around his legs, and so that is something that can actually cause some abrasion to his skin. So we wanted to monitor that and make sure that we didn't see anything there. And so we worked carefully with his caregivers to make sure that they kept an eye on things there. For people that might not be able to feel their feet yet with the neuropathy, but are still able to push and exert themselves, we get feedback from them on, every time they use the device, we ask about their pain location and level if they have any pain. And then we also ask them about their enjoyment level for the treatment. So those are good things, and that gets stored in the database. So we get to analyze that data, and we can see, oh well, no, I didn't enjoy this at all. Oh well, why not? What can we do better? And so we try and keep our finger on the pulse of what's going on. One of the things that we're developing too, we've got a separate app that we're creating to be able to assess other metrics that we're not doing right on the machine, things that they can report, a user can report back at any point throughout the day or night, about their own sensations, hey, well, I noticed that I felt stronger for about 3 hours, or I noticed my knee pain stayed at bay, until I went to bed. I woke up with it and then did another treatment and then it went away. So things like that, we're trying to create tools to make it easy for people to report back to us. So that's something that we have in development right now. I also have a customer feedback form for complaint handling if there is any complaints, but also if there are suggestions for improving features, improving protocols. We're always about taking on that user experience and capturing as much information about that as we can to help guide future design refinements, as well as to help us as we're coaching others how to use the equipment. For new customers, we're developing kind of a webinar series with multiple steps along the way. So if you want to watch them all right in a row, you can, but we designed it to be about 6 weeks long with one session each week to be able to provide guidance along the way and to get a facility, if it's a facility and not just an individual using it, to be able to get them fully up to speed so they're maximizing the use on patients that they might not have otherwise been able to treat so well. And part of that is going back and then meeting live remotely with them or in person to be able to capture that feedback from not just the end user, the patient who is receiving treatment, but also those who are administering treatment and the facilities themselves who are responsible for the equipment and the services being provided. And so that's a really important part. We're also, here at Rocky Knoll, as part of the QAPI study, they've got 20 residents that are, coming in here a couple times a week. They now have a volunteer coming in to help administer treatments. And so it's kind of a unique way to kind of deal with staffing shortages. So the equipment's been very easy for him to use. So he's been able to actually, in the month that they've had the equipment here, he's pretty quickly now been able to get on up to speed and to be able to assist others receiving treatment. And so we work with him, and we're trying to get as much feedback from him as possible as well. So, from the treatment administrators to the end users, we want to capture that information.
All right, thank you for that. I do have a follow-up question on the vibration. So since you said that you get back like the strength of the patient or the user, I was wondering, doctor, if, for example, have you met or have you encountered the situation where the vibration actually plateaued, so it sort of the sensation sort of like became a barrier to your patient instead of actually helping them?
Well, the very first time I used my first my first prototype, which was a pretty archaic contraption, using a drill motor, a washing machine motor to generate the vibration, a drill battery pack to generate things. I didn't know, I just knew I wanted to apply vibration in a certain frequency. And it was before I realized the amplitude, how many G's I was putting into my body would, I didn't even know I was stimulating muscle at that point. I was just trying to stimulate bone. But when I couldn't stand and walk, I realized that was probably a little bit too much. So we really refined that. That was around 8 G's of acceleration, which that's definitely too much to do for a 10-minute period, according to the International Standards Organization. So now we only apply less than 1 G of acceleration. So personally, I've experienced that where I call it wobbly leg syndrome, where your muscles become so fatigued. So our goal in designing the treatment protocol, for years, we've been really working hard to make it so a 10-minute session results in peak muscle performance. So the first minute, here's strength versus time. In that first measurement of strength, somebody's strength is right here. Well, after a minute of treatment, it's a little bit higher, 2 minutes a little higher. We want to see that keep going up, but it will eventually reach that peak, and then it'll come back down pretty rapidly to fatigue. So we're trying to get people to leave stronger than when they got there. And so that's, everything about the design of our protocols, our control software has really been to achieve that peak. And so with the data that we actually collect from every usage of the equipment, we can actually kind of learn as people are pressing on the device, we can see, are they pressing harder over time, or are they not gaining that strength? And so there's some real-time information that we're able to get back. And we're developing new protocols for different strength assessments to measure isometric strength and to measure other strength as well. Like with dynamic strength. So we're really trying to make this happen, where we can really make sure that somebody is stronger when they leave. I'll tell you another quick example. With one of our Vibetech 2 machine, it can go up to 150 pounds of pressure. And with the vibration maxed out, after about 4 or 5 minutes, I can fatigue one leg if I'm just doing a single leg press on it. And my wife called me a couple of times when I was doing that, and I'd only worked one leg. And so she'd be like, "Oh, do you want to go out for lunch?" So I would say, "Sure." And I wouldn't have treated the other leg. So I felt like I was walking in circles with one leg fatigued and the other one not. But that was by design. I'm sitting there trying to fatigue one leg at a time. But it's fun for me to toy around with. And actually, I encourage every treatment administrator to do treatments on their own on the device and anticipate the needs of the patients that they treat. Because I've solved, from having a device in our office and running some studies right inside of our office, getting to be the clinician that's administering the treatments, I've learned a whole lot about, the foot drop seems to happen with this muscle group here. Oh, if I press on this side of my foot, it's going to affect my ankle muscles where they can really engage. Or if there's some pain or some other situation, it really helps to be able to get your feet on this to learn and anticipate what needs somebody might have. So I do know of some examples of people who have some therapists that have actually gotten to work early so they can get their Vibetech treatments in before starting to treat patients. And a couple of therapists would actually start getting to work earlier and earlier and earlier so they could make sure that they got on it. So that's definitely a good testament of how well it makes people feel afterwards. But the effects typically last anywhere from 2 to about 4 hours after treatment, where the muscles remain activated. So I encourage everybody that does that struggles with an activity of daily living to do this before that activity. So it helps them because it overcomes some of those barriers to those physical activities that they're attempting to do. And it gives them the ability to tap into some smaller muscle groups and muscle fibers that might normally sit dormant, so that they can engage those muscle groups and muscle fibers in those new activities that they're doing, so that over time, maybe they won't need the treatment beforehand in order to call on those muscles to participate in those activities. But yeah, things become slightly easier for people when they have that increased muscle activation.
All right, thank you for answering my question. So we have a comment in the chat from Dr. Kumar. He said, excellent presentation, Dr. Leismer. I learned a lot about the therapeutic application of vibration. So thank you for that, Dr. Kumar. We're almost done. Are there any other questions from our audience? No more questions? Okay. All right. Actually, I have one last question. Yeah, about frailty. Have frailty, like older adults have really brittle bones, and sometimes even if you give them a small amount of vibration, they tend to have fractures. So how do you address these kinds of conditions?
So that was my, I pursued my PhD after coming up with this vibration technology as part of my master's program. And I pursued it in bone fracture mechanics for the explicit reason of preventing frailty fractures from occurring, because this is cyclic loading. And I wanted to make sure that the stimulus that we were providing would be a low enough magnitude that it wouldn't cause problems. The vibration intensity is so low that it's, about 1/20th of the strain that you would normally receive from taking a step during walking. So it's very, very minute vibrations. So even though that vibration, it's not causing bones to break down, it was previously thought that you needed vibrations to break bone down a little bit in order for bone to grow stronger. But Dr. Clint Rubin of the State University of New York, Stony Brook, discovered that low amplitude vibration, same frequency that we use, within the same acceleration range, that you can actually have anabolic or bone building stimulation from this vibration intensity without having to cause any damage to the bone. So we really are able to work with people at all levels. One of the things that I've developed now, iteration to iteration of equipment, we now have a real-time auto dosing feature built in to our leg press mode. So if somebody is too weak or deconditioned or has pain from pushing too hard, we whatever their tolerance is for how hard they can push, the resistance matches exactly what they can do in real time, and the vibration intensity scales according to that real-time exertion. So if they can only push a little bit or even just only rest their legs on it, it's a very, very gentle vibration. So they might get just 0.1 G's of acceleration at that point. But the harder they push, once they push out to the maximum on this machine of 100 pounds, they're going to be getting close to 1 G of acceleration. So the vibration scales with their ability to push hard. And the muscle strength correlates very highly to the bone strength. So it's kind of a nice intuitive way of delivering this to ensure that it's always going to be safe and it maximizes the progression. If somebody starts off small, they over time can start pushing harder and harder and harder and get more and more and more of a higher dose of the vibration as well as resistance. But very good question. Yeah.
Thank you so much for answering my questions, Dr. Leismer. So I think that's all we have for today. Thank you so much for your time. I'll stop recording now.
Well, thank you very much. I really appreciate